Alright, so let's start the presentation. So today I'm going to take you through the steps of configuring SSL or HTTPS for Administrator Console in PowerCenter 960. So the agenda of this meeting is to give a brief introduction of what is SSL, why use SSL, then all the terminologies involved in the SSL process of creating the certificates, keystores and truststores, and we'll also go through the utilities for managing the keystores and truststores, and how to enable SSL in PowerCenter 9.6, and how to enable SSL for Informatica Administrator and configure PowerCenter client tools to connect to an SSL enabled domain. So as part of majority of the security changes done starting 9.6, SSL was a major change. So the SSL or HTTPS for Informatica Administrator has already been there from the previous versions, but for the node processes or for the application services and for the client service interaction, all these communication channels now made secure starting 9.6 if you enable SSL for the PowerCenter server, in short for the PowerCenter domain. So you can still continue to enable HTTPS for Administrator Console, and you can also create or enable SSL for the PowerCenter domain. So these two work in disjunction. You can enable both, or you can disable both, or you can just enable for the Administrator Console alone, just as we used to do it in the previous versions. Okay, so starting with what is SSL? So SSL is the most widely used protocol for implementing cryptography on the web. So SSL is a combination of multiple cryptographic processes for encrypting the data transfer across the network. And if you take the OSI layer, OSI protocol model, SSL sits in the session layer. But if you take the TCP protocol model, the SSL protocol sits in between the application layer and the transport layer, typically in the application layer. There are many other protocols which rely on SSL, like if you use HTTP over SSL, then the HTTP transactions are sent across the network by encrypting it in the SSL. So the HTTP transactions are encrypted by the SSL protocol and sent across the network. So many other protocols rely over SSL, and typically when HTTP relies over SSL, we call that as HTTP secure, which is HTTPS. So that's why in PowerCenter documentation or PowerCenter we use HTTPS or SSL interchangeably, but it means that SSL is implemented and HTTP is using SSL. And for the nodes also the same process applies. So whenever we say SSL or TLS or HTTPS enabled, it all means the same thing at the end of the day on how you configure a key store and trust stores for the processes so that they can communicate securely. Okay, now on why to use SSL, because when we are transferring data over the network, it can be risky because of many of the following issues, because you cannot always be sure that the entity with whom you're communicating is really who you think it is. So anybody can act as another entity and send you data, and we may still continue to believe that it's the same entity that's sending us the data. Now, another problem is the network data can be intercepted across the network by some third parties, by any of the network sniffing tools, and this data could be decoded by them. And also any attacker who intercepts the data will also have a chance to modify it and relay it back to the receiver. So there are multiple problems. One, you do not know who's sending you the data, or you cannot really trust if that person who claims he is sending the data is the one who seems he is. And the second one is network data can be intercepted by any of the sniffing tools, so they would have access to the data. The third one is once data is intercepted, then the attacker will also have an option to modify the data before sending it to the receiver. So how does SSL address these problems? We'll go and talk about it in detail soon, but just to give a brief idea, when SSL server presents the certificates, the client will have to look at that certificate in its trust store and see that, okay, this is the person whom who's supposed to send the data, and he can trust the server. So that addresses the first issue of are we sure that the person who claims is sending the data is the one who he says to be. And the second point is because you're encrypting the data with SSL using the private and public keys. So there is a public key cryptography, private key cryptography, which is a different topic of discussion. But let's say when you encrypt the data with a key, the data is encrypted and only those who have the key can decrypt the data. So any interceptor cannot directly look into the data and understand what it is, right? And the encryption algorithms used with SSL will actually include secure hash functions, which will generate a digest similar to a checksum. So even if an attacker gets the encrypted data and changes it and modifies and sends it back, the checksum would change. So we would know that the data is modified or not modified based on SSL's secure hash function. So this way SSL addresses all the issues that that are seen with a channel or a network channel that doesn't have SSL enabled, or the vulnerabilities that a network channel has when it is not SSL enabled. Okay, so going into we'll start with a brief introduction of the terminology that we use when we enable SSL for PowerCenter and admin console. When we say a certificate, it's just a digital document that has the public key of the server, which identifies the server with other details like what is the organization to which the server belongs, what's the common name, and all these details will be grouped and bundled into a digital document which we call as a certificate. Now this certificate can be used to verify the public key of an individual. So a public key of an individual is the one that the client entities use to encrypt their data first. So in an typical SSL protocol, the initial handshake happens using the public key cryptography, and after that, during that session, they exchange a common key, and throughout that session, they'll use that common key to encrypt and decrypt the data. So in order to create that common session key, what we use is a public key to first identify if I'm talking to the right server. So again, in SSL, there are different ways of configuring, like a two-way SSL and one-way SSL. So with PowerCenter or with like many other applications, only one-way SSL is configured where the client has to trust the server. Anybody who's talking to the server will have to trust the server, and if they don't trust, the client will not relay the data back to the server. In a two-way SSL, the client has to trust the server, plus the server also has to trust the client if he's talking to the right client, right? In one-way SSL, the server has to be trusted by the client, and once the trust is established, the client and server keep talking to each other via the SSL channel. So the key store is a file that contains the private keys and the certificates and the public keys. So it's usually on the server side, because it is a server that needs to have its private key for decrypting the initial data sent by the clients. The clients will not have a private key because during this SSL key exchange, they do an initial handshake, and once the server is done encrypting the initial handshake messages with its private key, they exchange something called as a session key between the client and server, and the client uses that key to encrypt and server uses that key to decrypt, and vice versa. So that's why a key store is usually on the server side. It has the private keys, its certificate, and its public key. Now a trust store the format of a trust store is same as that of a key store. For example, if you take a Java key store JKS, the format of the trust store is same as the format of the key store, but it's just that the trust store will not have the private keys. They'll only have the certificates stored in the trust store, so more than one. The trust store can have more than one certificate in it, so that the clients will know what certificates to trust. For example, a trust store is configured on the client, a server is sending a certificate or presenting a certificate to the client. Client will look into its trust store and see if this certificate is already in its trust store. If it is there, then client would say, okay, I trust this server, and start the communication channel. If the certificate is not present in its trust store, then client would say, I do not trust this server, So I would not initiate a communication with this server. Alright, so that's the trust store. So essentially a key store and trust store are usually in the same format, but key store will have private keys, certificate and public keys, whereas the trust store will have the certificates. It would not have the private keys. Okay, so if a personal certificate is signed along with the signer certificate, which means the private key, the same file can be used as both trust store and key store. So because trust store is always a subset of the key store, the same trust store can be used with PowerCenter, or the same key store can be used as trust store for PowerCenter, but we always recommend to keep these as two different files, because there's no reason why we should expose a private key inside a trust store, so that the server's private key need not be exposed to the clients. So on the client side, you'll have only the trust stores with a certificate. On the server side, you'll have the key stores. Alright, so there are certain utilities for managing certificates and the stores. The first one is a key tool utility, which exists in Java bin or JRE bin. So with this key tool, we can create key stores, modify key stores in the JKS format, in the Java key store format. There are other formats of the key stores which we are going to talk about, but for operating on different types of certificates required for PowerCenter, you need OpenSSL as well. So we need the key tool and we need the OpenSSL to generate the certificates and key stores in the format that PowerCenter requires. Okay, so usually with SUSE Linux, you'll have a GenSSL cert utility which will be used to generate the certificates. Key tool is always essential on any platform, and GenSSL cert is very specific to SUSE Linux, where you generate the certificates in the PEM format. Alright, so there are different types of formats for key stores and trust stores. The Java key store format, the PKCS12 format, Microsoft Serialized Certificate Store. So PowerCenter for both admin console and for node processes currently supports JKS, Java key store, as the key store and trust store format. And we also use the certificates. We call the certificates can be of different types, like there is a distinguished encoding rules DER format, there is a PEM format, and there is a PKCS7 format, and many other formats. So PowerCenter uses the JKS key stores and the certificates in PEM format. As part of PowerCenter terminology, we call the PEM format files also as key stores and trust stores. So essentially, for configuring SSL in PowerCenter, both for node processes and admin console, you would have two key stores, two trust stores for node process, like one JKS key store and one PEM key store for node process, one JKS trust store and one PEM trust store for the node process, plus one JKS based format key store for the admin console process. So in total, you will have 3 key stores and 2 trust stores required for configuring SSL with PowerCenter, both for node and the admin console process. Alright, so starting 960, what is the process of how you enable SSL for the node, each node in the domain? So when it is a multi-node setup, all the nodes in the domain should use the same certificates, in fact the same key stores and trust stores. So if one node is enabled for SSL, all the nodes in that domain should be enabled for SSL, right? So we could ideally generate key stores and trust stores once and distribute the copies across multiple nodes, and then update the nodes pointing to these key stores and trust stores. So the generating key stores and trust stores is one step, and then after generating the key stores, distributing that across multiple nodes is the second step. But for generating the format, PEM format and JKS format, there are multiple steps. I'll go into the details of each of those steps. But what we do is, first we generate the certificates in PEM format for all the classic services like integration service and the repository service. Then we generate the key store for the node. Then we generate the trust store for node. Then we copy this trust store to the client machines. And now, because we cannot expose the trust store passwords in plain text on the client machines, what we do is we encrypt the truststore passwords with the PM password utility and configure it for the clients. And we also have to generate a key store for admin console. Now, for generating key stores or truststores for the node, we first have to generate a private key, right? So when we are generating a key store, as I said before, the key store will have a private key, the certificate, and the public key. So the first step is to generate a private key and a certificate signing request, CSR, using OpenSSL. So when you're configuring PowerCenter for SSL, it is not essential that we create the certificates on the same server. The certificates can be created on a different server. Maybe certificates could be created on some third server which doesn't have PowerCenter installed by your security admins, and then they can send the certificates to you. So, but whichever is the server on which we are generating the certificates, that server should have OpenSSL installed. Okay. So PowerCenter bundles with its own version of OpenSSL, and that will be used for consuming these certificates. For generating the certificates, you could use any external OpenSSL of any version and generate the certificates. Okay. So the first step is to generate a private key and the certificate signing request. So at the end of this presentation, I'm going to point us to some KBs and articles that are already written explaining the process in detail. So as of now, I'll be going through each step and explaining how we generate the key stores and trust stores for the node process. Alright, so the first step is to generate the private key and the certificate signing request using OpenSSL, and this is the command. So the details about the command are written in the KB, but we use the OpenSSL command to generate a new key with the encryption algorithm and the key size and the message digest algorithm, and we output the key into a file name .key and the certificate signing request into a file with name .csr. Okay, so this generates a private key and a certificate signing request. Now this certificate signing request, using the certificate signing request, we'll have to generate the certificate, right? So the second step is to generate the certificate. First step generates the private key. Second step generates the certificate and the public key. So in this OpenSSL command, we'll specify how long this certificate is valid, because if any organizational policy wants us to change the certificates often, or the certificate should get expired often, they would determine first how many days this certificate should be valid, and accordingly present the number of days in this command. And the input to this command would be the certificate signing request, the CSR file, and you would sign the certificate key with this private key, which would be the private key generated in the first step, and you'll output that certificate into a .crt format. That's what the -out parameter tells us, that the final certificate is outputted to .crt format. Okay, now so before going further, I'll have to explain that we look for a particular standard name for the key store and trust store files. So when you configure PowerCenter for SSL, for the domain and nodes, when you create the key stores and trust stores, the key store should be info_keystore.pem and info_keystore.jks, and the trust store file names should be info_truststore.pem and info_truststore.jks. Alright, so we expect for these standard names, and the key store and trust store files for the nodes should be created only with these names. For administration, Informatica Administrator Console, you can generate key store with any name and then update the gateway nodes to inform the gateway nodes that this is the name of the key store configured for Informatica Administrator. That process continues to be the same, but when you are enabling SSL for the node processes or for the domain, then the names of the key store and trust store files should follow this standard format. Alright, so we'll have to create a key store with the file name called info_keystore.pem, and that will be in the PEM format. So how we generate the PEM file? We got a certificate we generated a certificate in step 2, and also we generated a private key in step 1. So the private key and the certificate would be concatenated and sent to info_keystore.pem file. So this file will have the certificate and the private key, right? Now the fourth step is to generate the trust store. Now, as I said before, the trust store will only have the certificate, and the trust store will not have the private keys. So if you see the difference in step 3 for creating key store and step 4 for creating trust store, you would see that in step 4 I'm not sending the private key to the trust store. It will only have the certificate. But if you see the step 3, I'm concatenating the certificate along with the key into the key store. Okay, so this is the difference between key store and trust store. Key store will have the private key as well, but trust store will not have the private key. It will only have the certificate. Right, now we are halfway through of generating the key store and trust stores in PEM format. Now we need the key stores and trust stores in JKS format also, right? So PEM format is done, and now we have to have the certificates in JKS format. Now essential point here is that the same certificate that you have in the PEM format should be present in JKS format also. So in JKS format, we don't regenerate the certificates again, but we just import the certificates that we already created in the PEM format, right? Now, because it is not directly an X5.9 encoding in PEM format, what we do is we create an intermediary key store of PKCS12 format, okay, to import the certificate and private key into PKCS12. So what we do is we import the key store info_keystore.pem file into an intermediary key store called info_keystore.p12, right? And you'll specify the alias name of the certificate that we already specified here. Okay. So when importing the certificate into PKCS12 key store, you should specify an alias, any alias name for the certificate, so that you could identify the certificate. Alright, so the step 5 creates an intermediary key store in the PKCS12 format. So what we do now is, using this PKCS12 format, we now import the certificates and private keys into JKS format, right? So then now comes the key tool utility, because now we are operating on Java key store format. We'll now use the key tool utility present in Java bin or JRE bin to import the certificate and private key into Java key store format. So there is an import key store command. So all these commands are not specific to PowerCenter. In general, for configuring SSL for any application, we can use these commands to the key tool and OpenSSL. But I have listed the steps in a sequential order so that we know how we create certificates for use with PowerCenter. Now, the key tool can be used to import the key store. Now, as I said, there is an intermediary key store P12. So using the intermediary key store P12, import the certificates and private keys into a destination store of type JKS, Java key store. Okay, and the name of the destination key store should be info_keystore.jks, because that is the name that PowerCenter expects and looks for when it's operating in SSL mode. So in all these steps, wherever we have specified some text in angled brackets, that means you can give your values there, customized values there, and for all other parameters where the names are hard-coded, it means that PowerCenter requires those names to be present in the same format. For example, info_keystore.jks here. Okay, so step 6 with that command will import the certificate, public key and private key into the Java key store, the info_keystore.jks. Okay, and in step 7 we also have to create the trust store in JKS format. Now we already created a trust store in PEM format, right? So use the import cert command and specify the input as the info_truststore.pem, and the target keystore, or as I said before, there are no separate commands for generating keystore and truststore. Essentially, the format of the keystore and truststore files is the same. It's just that the truststores do not contain the private key, but the keystores contains the private keys. So for generating the truststore also, the command used will be with -keystore option. There is no separate -truststore option. We'll have to remember this because there are no different options for generating keystores and truststores. Only the process differs, but the format of the files is same. So even the truststore will call as keystore here, and we'll specify as info_truststore.jks, and we'll specify the alias name of the certificate that we specified when we used step 5, and import the certificate into this truststore.jks. Alright, so in this 7 steps, we'll be creating multiple files, with multiple intermediary files in these steps. But after the end of these 7 steps, the files that we are interested in would only be 4 files. One is info_keystore.pem, info_truststore.pem, info_keystore.jks, and info_truststore.jks. These are the only 4 files that we would be interested in after the end of these 7 steps. So there will be multiple intermediary files like the PKCS12 file, the CSR file, the CRT file, the key file, and all. They could be deleted after this process is complete. The PowerCenter is not going to use any of those files. PowerCenter will only be using the INFAKeystore, INFATruststore files. Okay. So this completes the process of creating the keystores and truststores for the node. Then we can also enable HTTPS for admin console. Now, as I discussed at the beginning of the presentation, when we say HTTPS, it means that we are enabling SSL, but we are using HTTP over SSL to access the admin console, because when we call the admin console in the browser, it redirects to the HTTPS protocol. So HTTPS is HTTP over SSL, HTTP secure, which means HTTP over SSL. So again, the steps of configuring it would be the same, but the only difference is for admin console, you don't need a trust store. You don't need to create the trust store, because for node process, for example, for a domain or for a node, there will be multiple processes which are like the clients. So the PMDTM is a client of PM server, and there will be multiple clients of the PowerCenter processes. But for admin console, the client is always the browser. We will only open the admin console in the browser, and the browser has its own trust store, which is Windows Trust Store already. That's the reason why when you use self-signed certificates and open admin console in the browser, you would see that the browser by default does not trust these certificates, because they are self-signed and not trusted by certificate authorities. So what I was saying is, for admin console, we only create a key store, because the client is always a browser and it will have its own trust store. We don't have to create a new trust store anywhere when we are configuring HTTPS for admin console. That's the reason why this process does not involve creating trust stores. So in that, the first step would be to create a private key and certificate signing request. So if you have seen for the node, in the process of generating keystores and truststores for the node, in the first step, we created a private key and certificate signing request using OpenSSL. So here, we create the same private key and certificate signing request using the key tool. By same, I mean this can be a different certificate. This need not be the same certificate that's used for the node process. As I said before, enabling HTTPS for admin console is a different process, and enabling SSL for node is a different process, and two certificates need not be the same, right? So for generating a key store for the admin console, we use the key tool utility, and we use the generate key command with all the details, like what should be the common name, the organizational unit, organization, locality, state, and country. This is the format in which the certificate expects its identity to be generated. and we'll give any alias for the certificate so that we could identify the certificate with the alias name. Then the key pass, the password for the key that the private key that we are generating, and the keystore file name. As I said, whenever we have it in angle brackets, that means that you can give any name for that option. So for admin console, you can give any name for the keystore file and the keystore file password. So for the key algorithm, we recommend using RSA because that's the strongest available of the ciphers that we support. And validity would be the number of days that this key should be valid. Okay. So the first step creates the private key and the certificate signing request. Then we'll have to create the certificate in the key store. For that, we'll have to certify the certificate signing request which we got in step 1. So we'll use the same key that we generated in step 1 because by the end of step 1, the file with this name, keystore filename.jks, will be created. And we operate on the same file, keystore filename.jks, in the second step and import or create a certificate with public key in the key store. The first step creates the private key and the certificate signing request, and the second step creates the certificate and the public key. And the third step is to verify the contents of the key store. All right. So this process completes generating the key store file for the admin console. And so after these steps, we are done creating the keystores and truststores for the node process and also for the admin console process. Now the next step is to configure PowerCenter to point to these keystores and truststores and enable PowerCenter with SSL. So for that, when the domain is up and running, that is at least one gateway node is up, run the update domain options command and set the TLS mode to true. Okay, so this ensures that the domain metadata is updated saying the TLS mode or the SSL is enabled for the domain. Now this option is required because, as I was saying earlier, if there are multiple nodes in the domain, all the nodes should be SSL enabled, right? So there should be an option at the domain metadata level that checks whether domain is SSL enabled or not. So for that reason, we run INFACMD update domain options and set TLS mode equal to true. So this sets the domain metadata to enable SSL configuration, right? Now for all the nodes all the gateway nodes in the domain, you'll have to run the update gateway node command to specify what is the admin console HTTPS port, what is the key store that you created for administrator console, what is the key store password, and set TLS to true. So this part, the first part of and giving the key store username, password, and HTTPS port is for the admin console, where you specify the complete key store file name. Now after that, for enabling HTTPS for the node processes, you'll specify these options: the node key directory, node key password, node truststore directory, node truststore password. So if you see the difference, for admin console property, you would specify the file name, but for the nodes, you will specify the node key store directory, because as I said, we go to the directory and pick the file names with particular format like info_keystore.jks. That's the reason why they cannot go into this directory with a different name, right? So you specify the node keystore directory, node truststore directory, and the passwords. Now we will have to ensure that the same stores, so copy the same stores across all the nodes and run update gateway node command on all those gateway nodes for enabling keystore or SSL for node and for the admin console. So on the worker nodes, the admin console would not on the worker nodes do not have the concept of admin console running on them, so you would not update the admin console key store, but you would still update the node key stores and the node truststore directories. So this command has to run when the node is down, when the services are shut down. So the first command, it has to be run when at least one of the gateway nodes is running. So at least the domain is up and running. So after these two commands, this command has to be run once on one of the nodes, and this command has to be run on all the gateway nodes available. So once all the gateway nodes, worker nodes are configured for SSL, you can bring up the nodes, you can start the services, and you can access the admin console. But now the clients have to connect to the SSL enabled PowerCenter, right? So on the client side, you should have the Truststores with the same certificate. So again, the Truststores will have a password. The Truststore.jks format Truststores will have the password. So encrypt the password using the PowerCenter's PM password utility, and set the encrypted password as an environment variable in INFASupport password on the clients, so that the PowerCenter clients like designer, developer, workflow manager, workflow monitor, they all can connect to the SSL enabled domain. So we'll have, so on the client side, you don't need the keystore files, because on the client side you only need Truststores. So you can copy the Truststores files only to the client side, and because you do not want to expose the keystores on the client side. So you'll copy the INFATruststore and INFATruststore.pem and INFATruststore.jks files on the client side, and you will have to set these two environment variables, info_truststore, that points to the directory containing these two files, and info_truststore password, which is this encrypted string generated by the PM password utility, right? So by default, PowerCenter ships certain certificates. The default certificates, you can choose to use the default certificates, but we would always recommend that you generate your own custom certificates and use with PowerCenter. If you still want to go with the default keystores or Truststore shipped with PowerCenter, on server side they would be present in services shared security folder, and on the client side the files would be present in client shared security folder. So if you are using the default certificates, you need not set the password, because we know the PowerCenter knows what are the passwords for the default keystores and Truststores, right? So you only need to set the INFATruststore environment variable to client's shared security, because the certificate files are already shipped with the client installer. You can set the INFATruststore to that directory. So starting 961, by default, if you have not set this environment variable, the client installer will automatically set the environment variable to the default folder. If you are using custom certificates, we'll just have to edit this environment variable and set it to the correct directory, storing the Truststores. In 960, you would have to set this environment variable. The installer will not set it even if you are using the default certificates. Right, so that completes the process of configuring keystores and Truststores for both administrator console and PowerCenter, and how we configure clients to connect to an SSL enabled domain. Now, as I was talking before, we already have some detailed KB articles on how to configure PowerCenter clients to connect to a domain with secure communication enabled, and we also have a KB on giving guidelines on how you can create custom keystores and Truststores to be configured with PowerCenter. So starting 9.6, there is a new document called PowerCenter Security Guide, which contains all the aspects related to the security related implementations that are made starting 9.60. So for details related to Kerberos, LDAP, SSL, and many such security related functionalities, we could also refer to the PowerCenter Security Guide, and you can refer to the chapter Domain Security for knowing on how we enable SSL for PowerCenter node and administrator console. So that completes the process of how we create keystores, Truststores, and how we configure PowerCenter clients to connect to an SSL enabled domain. And I'll open up for the questions now. So if anybody has any questions on the process of creating keystores or Truststores, or how we configure PowerCenter clients, we could start that question and answer session now.
Presentation mode is now disabled.
So if any of you have any questions on the process of creating or configuring PowerCenter, you could start asking the questions now.
This is Joel from Mosaic.
Hi. Yeah.
My question is, so these SSL connections are for the client and the services to communicate. This is not to connect to an external entity, correct?
That is correct. So starting 9.6, the SSL is enabled for client to domain communication, inter-service communication as well. So even when the services like integration service, repository service talk to each other, that communication is also encrypted. And when the clients talk to the domain, either the PowerCenter client or the developer clients talk to the domain, even that channel would be encrypted.
Okay, so but it's just the communication between the tools themselves, right?
That is correct.
Okay, thanks.
Hi, this is Ashan. Sorry, joined late, but I have a quick question. So, is this going to be effective? The SSL HTTPS going to be effective on analyst service and metadata manager service also?
Yes, for all the services in the domain, yes.
Thank you.
This is Rob Schaller. I have a clarification question, please.
Sure, Rob, go ahead.
Okay. To encrypt between source and target, okay?
So which case are you calling for?
Pardon?
Which case are you calling about?
What company or what? I'm missing something here. What?
Sorry, can the other guys please mute their lines so that Rob can be clear to go ahead and ask the question? Yeah, Rob, go ahead.
I understand the domain is communicating from the clients and servers, okay? What my next question is if security is needed to be implemented between the source and targets, that's done external to Informatica then, or what?
Yeah, so that is done external to Informatica because let's say you're reading from an Oracle server and the Oracle server supports encryption. You'll have to configure the Oracle client to read via the encrypted format. For example, if you are using ODBC with the data direct ODBC for Oracle SQL Server, there are ODBC options to enable SSL. So enabling SSL is outside the purview of PowerCenter there, but you can configure the connection to use the Keystores and Truststores and read the data in an encrypted format. So ODBC, the DSN will have certain properties that you can set to read the data in encrypted format, and with the assumption that the server, the database server is already encrypted, already configured with SSL.
So if it's all within Informatica, then the percentage of overhead added for doing secure, isn't that severe then?
So the overhead in terms of configuring PowerCenter, no. For reading the data from source and target, the PowerCenter server need not be SSL enabled. They two work in distinction. So your ODBC DSN just has to be configured for the Keystores and Truststores so that the data is read in encrypted format. That is a simple configuration in ODBC INI file.
That's just done, and that's just done at the handshake.
No, there the handshake happens between the ODBC driver and the database server. It doesn't happen directly with the PowerCenter server.
Okay, thank you for the clarification. Appreciate it.
And just to clarify that more on the domain side, for creating the domain on a database, we have certain databases like Oracle, SQL Server, all certified, right? So we ship our own version of JDBC driver. So starting 9.6, even those JDBC drivers are certified for SSL. So if you have an SSL enabled Oracle server on which you are installing your domain, you can use our driver starting 9.6 to pass additional parameters with Keystores and Truststores and secure the communication between domain database and PowerCenter as well. So all those details are included in the security guide.
Thank you.
All right. So are there other questions?
Yeah, Saradhi, my name is Krishan. I hope I'm audible.
Yeah, Krishan, you're audible. Go ahead, please.
Yeah, Saradhi, thanks for the PPT. That was really informative. I just had one doubt. I've seen that for every certificate configuration, the limit is given as 365 days. So is this like based only on security, or is it like there's a limitation on the validity of the certificate that you can have?
No, there's no limitation from PowerCenter on the validity of certificate you can have. It only depends on the organizational policy and the general cryptography standards. PowerCenter does not restrict that the certificate should be valid only for 365 days. It doesn't really restrict that.
Okay, so the only disadvantage that we have is that, after 365 days, we'll have to renew it. That is, do the same procedure once again?
Correct. But otherwise, if you see the default certificates, they are valid till 2040. So you can create the validity of the certificates as much as you want to, and you can configure PowerCenter to use those certificates. But the reason why we recommend having them, let's say for 2 years or 3 years, is because organizational policies may demand changing the certificates so that you consistently ensure the certificate security, right? But as such, PowerCenter does not restrict it to 365 days.
Okay. And then just one final thing. Would this PPT be available in the Informatica website later on if we needed to?
Yeah.
Because I think that there's a lot of...
Yeah, later on the PPT would be made available on the FTP site, and even the video would be made available on Informatica support channel.
Oh, that'll be great. Thank you.
So there was a question on the chat window from Ashan asking if Informatica supports SSO, the single sign-on. So for single sign-on, if you're looking for single sign-on across multiple client services, the Kerberos configuration that is introduced in 9.6, starting 9.6 can be used because Kerberos supports SSO. If you have a Kerberized domain, then for example, if you're logging into a Windows laptop on which you have the PowerCenter clients installed, we do not prompt for username password again, and we just authenticate with your same Windows user. So that kind of a single sign-on is supported with Kerberos starting 9.60. Yeah, thanks, Ashan. So, are there any other questions?
Hi, it's Christoph here. Just one question. The way it's been presented here is that the TrustStore should be copied to the client machines, and then there's environmental variable set to point at that TrustStore at the client machine. Is it possible, alternatively, like Windows built-in like functionality, and just import the certificate so the client can talk over SSL to a server?
Yes, you can import the certificates by creating a TrustStore on the client side. Yeah, you can do that, but the steps are given in such a way to simplify the process so that you can directly copy these files, because most of the security administrators do not want to expose the certificates to the clients, right? They might just want to give the TrustStore directly. That's the reason why the steps include copying the TrustStore. But if you already know the process of creating a new TrustStore on every client and importing the certificate, that can also be done. The requirement is that the TrustStore contains the certificate that is presented by the PowerCenter server. You copy the TrustStore file, or you create a new TrustStore and import the certificate. It's all the same as long as the same certificate is present in the TrustStore.
Okay, thank you.
Hi, I have another question. I might be asking a very stupid question, but most of the organization would have an internet wherein they will be having a firewall set if there are any external requests that is coming on into their server. So what exactly would you think of as a use case, a peculiar use case wherein you still go ahead and have this HTTPS set?
So the most typical use case would be somebody internal to the organization intercepting the data. Let's say I sit inside the firewall, I run as an application from inside the firewall, and I have access to the whole data that's transferring across the network, right? So any internal application, even though it's not intended to access the data, anybody can access unencrypted data over the network. That's if you're sitting inside the firewall. Now you still have to encrypt that data to make it secure within the organization as well, right?
Thank you. I understand it's similar to SFTP or IFTP. Normally,
correct.
What you do even though if they have the firewall set.
Correct. Yeah.
Am I correct?
I have another question. This is Joel.
Yeah, Joel, go ahead, please.
Do you have, is there another, is there like a GUI version of the configurations? I noticed that everything that you went through was all command prompt.
But if you are configuring SSL when you are installing or upgrading PowerCenter, then it's, so if you're talking about the configuration, the installer will give you a GUI mode, but for creating, the process of creating the keystores and truststores is command line. There are certain utilities available, open source utilities to have GUI like the port C. There's a famous command line, GUI based utility called port seal, and there are many such open utilities, but the creating the keystores and truststores is usually done by the security administrators via the command line, because these command lines are intended only for creating these security keystores, truststores, and certificates. But on top of these command lines, there are GUI based utilities which again internally consume the same commands.
Okay. So we see, have you guys seen any benefit from having internal key stores that are generated by the PowerCenter versus the ones that we could buy externally, which is usually the norm?
So the key stores, there are three different types there. One is the keystores and truststores generated by PowerCenter. The other one is keystores and truststores generated by your internal security teams. The third level is having the certificates from some trusted third-party authorities, right? So if you are using the default one shipped with PowerCenter, the configuration becomes easy and you don't have to worry about much of the passwords and how to configure those keystores and truststores. But we ask customers only to use that as a guideline. The benefit benefit of using your own keystores is that it's specific to your organization and stays within your domain. If you are using the default keystore, that's what we ship across different customers. So there may be different ways of using those keystores and truststores. Others will also have the same encryption standards. So that's the reason why we recommend customers having their own keystores and truststores. But if you buy from a trusted third-party authority, they are trusted certificates. So you can either choose to generate these yourself, self-sign, or you can choose to get it from any trusted third-party authorities like VeriSign. Okay. So there was a question on how is the data transferred using Informatica PowerCenter? Is it also now encrypted using the new process? So I think Gaurav, for answering Gaurav's question, this question has already come before. I've informed that if you are using the ODBC drivers, in the driver configuration DSN, you have certain parameters like validate, certificate, the truststore, keystore, everything. You just have to configure those, and the ODBC driver takes care of encrypting and decrypting the data transfer when it's reading from the database server. PowerCenter would not do anything there, but it depends on the ODBC driver. And some of the ODBC drivers, DataDirect ODBC drivers, have the options to read and write in an encrypted format.
Would there be any performance degradation also?
Performance, as such, with any SSL, performance degradation is not from the PowerCenter side. You would definitely see that there's more data getting exchanged across the network because the entire data now has to be encrypted in the SSL channel and sent through the network. So there is no additional performance degradation induced by PowerCenter. Whatever is the network delay in enabling SSL will still remain. Yeah, there's more traffic than when you don't enable SSL. But PowerCenter by itself does not induce any delay because of SSL.
One more question. I know you mentioned in one of your references, the last slide that you have on your screen, you said you have a PowerCenter 96 security guide. Would that have all the information that you presented today?
Yes, that would have all the information presented, most of the information presented today, and anything you don't find there, you could actually find in the KBs. Whatever I presented today would be present in the KBs as well as the security guide. If you want to learn more on how you configure security and how it helps, security guide is the useful one. But if you want to go into detail in each point on how you create, how you configure, you could also refer to the KBs. But yeah, security guide will cover a bird's eye view of all these details. Yeah.
Thank you.
I have a question.
Sure, go ahead.
Yeah.
Go ahead, please.
Yes. In our environment, we rely heavily on DR, and our DR is SRDF. Production to DR is SRDF. So when we invoke DR, would we need to do any adjustment, like update domain with, and do we have to regenerate keys because it's a different box, or everything should be the same?
So when you have the DR domain, when you're configuring the primary domain for SSL, I would recommend having your DR domain also SSL enabled with the same certificate, so that you don't have to re-update the passwords on the client machine.
Yeah.
But for DR, it's like mutually exclusive. We have production up and running. So, and for DR, and DR is sleeping. So in DR, we have DR up and running and production is sleeping.
Correct.
So in that case, yeah.
So only when I'm talking about the context when DR is up and running. Let's say only production is running, you would only connect to the production environment, right? Now when the DR comes up, if you have the same certificates used, same key stores used in the DR domain also, then you need not change any settings on the client side, right? Because on the client side, you'll have to set INFASupport and INFASupport password environment variables. If you are using different certificates, you will have to change all the client machines with a new password, new DR passwords again. If you are using the same certificates on DR, there is not much difference from the process what you follow now. You bring up DR and you connect the same way as how you connect now.
Okay. Okay. One more question.
Sure.
With 9.5 and up, we saw the product that Java is not coupled with the product. So the Java directory is like the home directory that we need to invoke is at the OS level. So when let's say we had an installation for CRM and we had the same similar to create the public key, the private key, but we use the Java directory that's not with the product. Here with this presentation, we saw that the Java directory is under the home directory for Informatica.
Right. So starting 9.5, so Java is bundled with PowerCenter except for AIX, HPUX, and Z-Linux platforms. So if you are using Linux or Windows or Solaris or any other platform other than AIX, HPUX, and Z-Linux, you would see Java bundled. For these three platforms, you will install certain version of Java to work with PowerCenter. You can use the same key tool inside that Java.
Okay, so it doesn't have. It's not going to be the PowerCenter home directory. It has to be the Java like OS Java directory.
Correct, for AIX, HPUX,
AIX.
Yeah.
Okay. Okay, just confirming this part. Okay.
Yeah.
Thank you.
All right, so we are on time, and there are we can take one or two more questions, and then we can wrap up the presentation. Yes, please go ahead.
Yeah, I have one question actually. I was asking, can you actually basically encrypt the data, the data which is actually created on the Informatica side, like the lookup files and stuff like that? So is that being taken care of while we are securing the domain and the node, encryption? Will that be taken care of, or will that be a different topic?
So are we talking about the cache files? Only the cache files?
Yeah,
or
exactly. Yep.
Yeah,
yep.
and that's a different, that has not been changed in 9.6, but that's a different topic in itself altogether. There's no concept of SSL there.
Okay, so those
they continue to
between the...
Yeah.
So those communication between the sources, or I mean, you know, or when
no,
those files are getting created.
The communication is again SSL encrypted because the data sits inside the PMDTM itself, and any process, let's say a session is talking to integration service, reading this data, all that communication is encrypted. If you're talking about the file in itself, the file does not have anything to do with SSL, but the read and write to the file is always SSL encrypted once you enable node processes for SSL. All the processes that interact with each other inside the PowerCenter domain go via the SSL if you enable SSL at the node level.
Okay. So but the file remains de-encrypted, but the communication between you're saying the integration server and all the will be part of the SSL. Okay.
Yeah. So if you see integration service starting 9.6, there will be an additional option called enable data encryption. If you check that option, then anything talking to the integration service via any, let's say, repository service or PMDTM, anything talking to the integration service, that channel would be encrypted.
Oh, I see. Okay, thank you.
All right, so we can take one last question.
One more question.
Go ahead, please.
Yeah. So on AIX, if we opt to use the keys shipped by Informatica, and they are under the Informatica product directory, should we move them to the Java directory?
No. Only the key tool. Correct. So you can leave. You will have to leave the Keystores and Truststores in the default directory. Only the key tool utility used for generating the Keystores and Truststores is in the Java directory. The Keystores and Truststores can be present in any other directory.
Okay. Thanks.
All right. So if there are no other questions, I'll wrap up the call, and thank you all for joining the presentation. The presentation will be posted soon on Informatica support site, and the video would be hosted on YouTube Informatica support channel. Thank you all. Thank you.
Thank you.
Thank you.